Okay, so now to talk about pyramids. So we don't really have to talk again about what volume is because now we understand what volume is. We're kind of filling however many of the bases there are, which would be represented by the height. So we find the area of the base and we multiply it by the height of the prism. Here we have to first understand what a pyramid is. So a pyramid is very different than a prism because it only has one base. And because it only has one base, there's nothing to be parallel to. Okay? And again, you can say like what it stands on. I guess that would be more true for a pyramid, but it doesn't necessarily have to stand on its base, but it just has one. It has one base and your several other faces. Okay, so examples of pyramids could be your cone with a circular base, your rectangular pyramid down here with a rectangular base. There could be a square pyramid with a square base. Here's a pentagonal pyramid that has one pentagon base. There's a triangular pyramid, which would have one triangular base. Again, pyramids are also named off of their bases. So whatever shape the base is, that's how it kind of reads what type of pyramid it is. So it's with the cone being a slight exception to that, but your rectangular pyramid has a rectangular base and so on. So they also have a very general form to follow, but your pyramids are very unique because what they are is actually 1/3 of a particular prism. So the cone is actually 1/3 of a cylinder. Okay, your triangular prism is going to be 1/3 of a rectangular prism. So all of these things are, of a triangular prism. And then of course your rectangular prism is 1/3 of a rectangular pyramid is 1/3 of a rectangular prism. So because these are 1/3 of all of your total prisms, we actually just will find our volume by doing 1/3 of the way that we found the volume of our prisms. Okay, so this is how you find the volume of your prisms. And because your pyramids are 1/3 of a prism, we find the volume by taking just 1/3 of the prism's volume. Okay, so a lot of this is going to be much the same. The biggest difference here is we're going to have to take 1/3 of something. Okay, so let's go ahead and we'll start with a square pyramid. Okay, so a square pyramid is going to have a square base. So I'm going to start this the same way. Of course, I do have that 1/3 in front, but I'm going to worry about that later, not now. Okay, where the big B is the area of the base, right? Here it would be area of a square base. Okay, so it would be side squared or length times width or base times height. Either way, 20 squared is 400. So 400 centimeters squared. Okay, so now I have 1/3 of 400 and the height of the pyramid. It's very important that you have here what's a lateral height or a slant height, it could also be called, and a height for your pyramid. Okay, the height for your pyramid has to be perpendicular from the top to the base. Okay, this would be a lateral height, which is a height of that triangle. So each of these 4 triangles, they're actually the same triangle because you have a square base, but each one of these triangles has a lateral height or a height of 26 centimeters. But that's the height of a triangle. Okay, the 24 centimeters is the height of the pyramid. Okay, and that's the one that we're going to need to use here. Okay, so the height of the pyramid would be 24 centimeters. So at this point, it's just a matter of using your calculator basically to do the tedious math. So I have my area of my base times the height of the pyramid is going to be 9,600. Then I'm just going to simply multiply by 1/3 or divide by 3. So my volume here, 3,200 or 3,200 centimeters cubed. Okay. Let's take a look at a cone. Okay. Cone is different because it has a circular base. So because it has that circular base, you know that you're going to be including pi with this. Okay. But the process is much the same as the cylinder and not very difficult. So the area of the base is going to be a circle. Okay. Which, just like when I did the cylinder, is going to be pi r squared. Your cone here has a radius, or its circle has a radius of 4. So the area of the base, 16 pi. Okay. The height of the cone is also from the top of the pyramid, okay, perpendicular to its base. So that would be the 16. And 16 squared is something that we've worked with a few times this year, but just use your calculator or mental math. 256, and of course don't forget that pi. Last thing I have to do is multiply by 1/3 or divide by 3. Okay. This one's not going to be even, so you can either use a decimal or you can simplify if you like to. I'm sure most of you would prefer using a decimal, so I'll just carry through with that. Okay. Leaving it as 256 over 3 would be acceptable too. So if you wanted to, you could use it 256 pi over 3 would be totally acceptable. Okay. Oh, and we should include our units, so meters cubed. Okay, and that, I think, should sum it up for a pyramid.